The table below lists a random sample of 50 speeding tickets on I-25 in Colorado. If a random ticket was selected, what would be the probability that the driver was female? So the table might make a little more sense if I separate out the total row and columns from the headings. Okay, so there's 15 females in this study out of 50 in the study altogether. So that's the probability of a female, which is 0.3. Now, given that a particular ticket had a male offender, what's the probability that they were more than 20 miles per hour over the limit? So it's given to us that we have a male offender. So that's the restriction. Now, what's the probability that they were more than 20 miles per hour over the limit? So there's 15 that were more than 20 over the limit out of 35 males altogether. So 15 over 35, that gives a probability of 0.429. Given that a particular ticket was 10 to 20 miles per hour over the limit, so that's our restriction now, so we're only concerned with these numbers in the table, what's the probability that the driver was a female? So of that group, there's 9 females out of 20 total in the group. So 9 over 20, .45. If a random ticket was selected, what would be the probability that a driver was a male? So we're selecting out of the entire group now, and there are 35 males and 50 total. So 35 over 50, that's 0.7. If a random ticket was selected, what would be the probability that the driver is a female and driving 10 to 20 miles per hour over the limit? So the "and" with contingency tables tells us to look at the intersection. So the group female and going 10 to 20 over. There are 9 females that are going 10 to 20 over the limit. But it's not over 20 because this isn't a given probability. This is over the entire table because "and" probabilities, you're still over the entire population for the table. Given probabilities is when you have a reduced population to work with. So 9 over 50. And 9 over 50 gives us 0.18. If a random ticket was selected, what would be the probability that the driver is a female or driving 0 to 10 over the limit? So we have 2 events, female driving 0 to 10 over the limit. But these are joined together by "or," which tells us to add probabilities together. We just have to be careful for overlap. So the probability that a driver is a female, there's 15 females, 0 to 10 over, there's 11 in that group, but there are 2 that get counted twice. So we have to take 15 plus 11 minus 2 that were doubly counted out of 50. So 15 plus 11 minus 2 divided by 50, that's 0.48.